What's up, party people? It's Mr. Harris again, and we are first of all, we're going to talk about you subscribing. If you're a student of mine, or if you're just a random person watching this live or the replay, do me a big favor: like, share, and subscribe. For my students, share with your friends that you know aren't watching the videos. There's a lot that you can pick up from these videos outside of the classroom. And so, yeah, we're talking about lesson 3 from unit 6. And this one is just talking about patterns and tables um, with exponents and how these tables and patterns look when we're dealing with the exponents, right? So let's go ahead and get right into this. I am going to share my screen and we are going to look. Let's see, let's present this. All right. So when we look at this, you want to be able to recall the meaning of exponents by analyzing patterns and expressions. Okay, so somehow we're going to have exponents in here in an underlying way. So let's get right into it. A homeowner wants to build a garden with concrete tiles around the outside. He has room for the garden to vary in length, but not width. He's not sure what size he wants the garden to be. Here are the sketches of gardens that are 1, 2, and 3 meters long. The homeowner needs to know how many concrete tiles will be needed for different possible garden lengths. Okay. So as you can see at the bottom, one of the things that I want you to keep in mind is this green area in the middle is the garden. So here, that's the garden. It's 2 meters. And as you can see, each tile looks to be 1 meter in length. Okay. So when I look at this, we're basically going to count the number of tiles here. So let's clear this one and go to the next slide. So when I look at this, notice we're going to count the number of tiles. So boom, 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 boom. So I have 3 over here, 3 over here. That's 6 plus 2 is 8. Okay. So we have 8 meters or 8 tiles. Here we have 3, 6, 7, 8, 9, 10 tiles. And here we have 3, 6, 7, 8, 9, 10, 11, 12 tiles. Okay. And so create a table or show how many tiles will be needed if the garden is 1, 2, 3. Create a table for the 5. Let's see. Let's do this. Create this table. It doesn't have to be that long, but here, boom. All right. So if we want the, we're just drawing. If we want the tiles, the number, let's see, 4 meters. So we're going to say meters. And then we're going to say tiles. Okay, so 4, 5, and 6. All right. So notice the number of tiles is increasing. When it was 1 meter, it was 8 tiles. When it was 2 meters, it was 10 tiles. When it was 3 meters, it was 12 tiles. So it looks to have a pattern of the tiles increasing by 2 each time. So when I go from 3 meters to 4 meters, it's going to be 14 tiles, and then 16 tiles, and then 18 tiles. Okay. So if we describe the way the pattern is growing, it is the number of tiles is increasing by 2 for every increase in length of 1 meter. And that's it. All right. So that's that. Let's clear this out and go on to the next one. All right, this one, I like this activity, right? Because this activity, let's go back. This activity, you want to take this and you want to match. So we have some lists, right? And so we want to match a expression from list A, B, and C. Okay, so there's a list, or there's 3 lists, and from each list you can match a another expression from the next list. I want to start with the simplest one because most kids work better with powers of 10. So I have 10 times 100, right? And so notice if we go over here, that's going to actually match with this, because if we multiply a power of 10, you all probably are familiar with the math hack that tells you if you have powers of 10 that are being multiplied, you take a 1 and then add up the number of zeros. So here you have 1, 2, 3 zeros. So I have 10 to the third power. So boom, that matches with that. And then 10 to the third power is 1 and 3 zeros. So that matches with this. All right. Let's do a different color. And then now let's go with the bottom one right here. Notice we're adding, and there's 1, 2, 3, 4, 5, 6 threes. Okay. So if I have 6 threes being added together, then that's basically 6 times 3. And then 6 times 3 definitely equals 18. So you have that. Now we're getting a little more tedious, right? So let's go with purple this time. So I'll go with the 8 times 8 times 8, right? Now this one is a little tricky, but if you notice, 8 times 8. So here I'm gonna go down here, right? 2 to the third power equals 8, and 4 to the third. So if I have this matched up, we can cancel that with that 8. So I have 8 times 8, and then this 4 to the third is 4 times 4 times 4, which equals 64, and 8 times 8 is also 64. So we're going to match those two. And so we have 8 times 64. Same thing. And then now let's see, which one does that match up with? Well, 512 if we multiply 8 times 64. Let's go here. 9 times 3. I'm sorry, 9 times 27 times 3. So we're left with either one of these two. It's kind of obvious that it's going to be this one, but let's see how it matches up. 3 to the second power is equal to 9. And then we have 3 to the fourth power, right? So 3 to the fourth power is the same thing. 27 is 3 to the third power. And then 3 to the third power times 3 gives me 3 to the fourth power. So that matches there. And then if we multiply those out, we will get 729. Last but not least, we're left with, let's go green, 1/4 times 1/4 times 1/2. It's going to naturally match with this one because this is the only one left. But you might say, well, how do we get 1/2 to the second power? Well, 4 is the same thing as 2 to the second power. So what we technically have is 1 over 2 to the second power times 1 over 2 to the second power times 1 over 2. And then how do we get that fifth power? There's 2 powers of 2 here, 2 more, so that's 4, and then 1 more, that's 5. So that's how we get that. And then 1/2 taken to the fifth power is 1 to the fifth power over 2 to the fifth power, and 2 to the fifth power is 32. All right. Let's clear this out. And here we have a scenario. We have this scenario where Claire has a summer job. She wants to save money to spend for over the family vacation. She's saving $5 per week for each week, for a total of 10 weeks. And then you have Tyler, who has a summer job, and Tyler is going to start by saving $2 for the first and second weeks, and then they're going to double their money each week for 10 weeks. So the third week they're going to have $4. The fourth week he's going to have $8, and then so on and so forth. So let's go to a table to figure out how this is going to look. Now, notice it said that Claire is going to save $5 each week. So 5, 10, 15, so 20, 25, 30, 35, 40, 45, 50, And then we got to figure out if X is the number of weeks. Well, how do we do that? 5 times 1, 5 times 2 is 10, 5 times 3 is 15. So we just simply say 5 times X. Now, let's look at Tyler. Tyler's money doubles each week. So it starts with $2, then 4, then 8. We double that. Remember, double means multiplying by 2. 16 times 2 is 32. 64, 128, 256, 512, and then 1024. Okay. Now, this one, what we want to figure out is how do we come up with an expression to represent the amount of money that Tyler has each week? Well, notice this is like 2, and then this is 2 times 2, and then this is 2 times 2 times 2, and then we continue that pattern, right? Let's change the color of this, okay? And then, all right, so after 5 weeks, there's 5 2s. 6 weeks is going to be 6 2s if I can fit them in here. All right, and then it will be 7 2s. So actually what we have here is 2 to the x power, because remember, exponents is multiplying that base by itself, the exponent number of times. So here in week 7, we will have 2 multiplied by itself 7 times, okay? And so this is showing you how to get into the patterns of how exponents work. Notice Claire, theirs wasn't saved, or their savings was the same amount each week. So it's not growing exponentially. All right. But Tyler, theirs is growing exponentially because they're doubling that amount every week. All right. I think this is the last of this slide or this lesson. It is. All right. So one of the things you want to look at in this is you want to be able to understand the difference between 3 times 5. And so this is, and this is not the same. 3 times 5 is just that. 3 to the 5th power is 3 times 3 times 3 times 3 times 3. Okay, which I think it's I know 3 to the 4th power is 81, so 243. All right. We're not going to look at this table. It says what are equivalent ways to write 4 to the 5th power. So we could say 4 times 4 times 4 times 4 times 4. Or we could say 4 to the 2nd power times 4 to the 3rd power. Or we could say, we could do, let's see, 4, let's do a different way using the quotient rule. We could say 4 to the 7th power over 4 to the 2nd power. That would simplify to 4 to the 5th power as well. So just a couple of different ways to write that. We could also say something like 4 times 4 to the 4th power. So any combination of exponents that add up to equal 5, because it's 4 to the 5th power. And that's this. This is just an introduction to looking at the patterns, the tables, and things like that. Please make sure you like, share, and subscribe. Go back through if you're working through your workbook, write these things down. And thank you so much for watching. And we'll see you on the next lesson. Deuces.